Welcome. So what I want to do is show you what do you have to know to be able to solve, or I'm sorry, graph a quadratic when it's in standard form. Now, obviously, one of the ways that we don't go in this course, but is to convert it to vertex form and to graph it that way, but that's a whole nother course and a whole nother situation. So let's say we want to graph it, in the form that it's in, which is be in standard form, which is y equals ax squared plus bx plus c, where a, b, and c are all going to be real numbers. So the first thing we need to understand is, if we're going to be graphing, we need to kind of know what is the shape of going to be a quadratic. Previously, we've learned how to graph, linear equations, which produce a line. When we have quadratics, they're going to produce a parabola. And that parabola is going to be kind of what we have as U-shaped. And it could either open up or it can open down, all right? So one thing we need to know is we need to know exactly what the shape is, as well as some important points. Like the bottom of it is what we call the vertex, or the lowest point. And the highest point is also the vertex if the parabola opens downward. So understanding the shape is going to become very, very important, at least so you know what the graph is going to be looking like. The next thing is not only understanding the axis of symmetry, but being able to figure out how to find the axis of symmetry. Because the quadratic equation or a function is what we call an even function. And what that means is it is symmetrical about a vertical line. And that vertical line is what we call the axis of symmetry. And this is very, very important when graphing quadratics, because therefore we know whatever one side of a quadratic looks like, we can just reflect that over the axis of symmetry, and that's what the other side is going to look like. So to find the axis of symmetry, since it's going to be a vertical line, it's going to be x equals opposite of b divided by 2a, where b and a are going to come from the quadratic equation that you are, or from the problem that you are given. So knowing the shape, the vertex, as well as understanding the axis symmetry. The next point is evaluating points. And I think this is one of the biggest or one of the most important concepts that students need to understand when graphing in general. When we look at a line, remember the definition of a line is a set of infinite many points, right? So, if here's my line, there's infinite many points that lie on this line. And each and every one of those points are made up of x and y coordinates. And to determine if a point lies on a line, so let's say the equation of this is y equals 1/2 x minus 1. To determine if a point lies on the line, what we simply do is plug in the coordinate. Let's say we want to see, does the point 4, 2 lie on this line? Well, that's the x, that's the y. So we can plug them in and see if it makes the equation true. So I plug in 2 in for y, and then 1/2 times 4 in for x minus 1. So 2 equals 1/2 times 4 is 2, minus 1, 2 equals 1. That does not equal each other. So therefore, 4, 2 is not a point on the line. The same thing is true with any function or equation that we're graphing. We need to know how to evaluate the points. And this becomes very important, especially when we want to see what points are on the graph. So when I say evaluate points, specifically what I'm talking about is creating a table. And usually we want to create that table once we've figured out the axis of symmetry. So once we figure out the axis of symmetry, we know what one point is, or we know one point because the vertex always goes to the axis of symmetry. So let's just pretend we have an xy table. We figure out the axis of symmetry, and let's pretend the axis of symmetry is 1 for this example. Well, then all I simply need to do is figure out what are maybe 2 or 3 points, depending on what your teacher wants or what it's asking. But pick at least 2 points to the left of that axis of symmetry to evaluate for. So then maybe I'd say 0 and -1. And to evaluate them, I know the x value. I need to figure out what is the y value that's going to make the equation true. Because we want to find points that when we plug in are going to make it true. Not true, because we want to find the points that are on the line. So what we do is you just plug in your variable x, the value for x, to solve for y. Then once you know those 2 points, you can just reflect them over to find the other 2 points on the other side to create your parabola. The next important thing is understanding the vertex. So we know that the axis of symmetry goes through the vertex. So we know the x coordinate. So to solve, to find the value for the y, let's pretend I have an equation, y equals 2x squared minus 3x plus 1. All right, so let's say I have my axis of symmetry as 1. So therefore, to find the y value, kind of going back to what I was saying, evaluating points, we want to find the y. So we're going to plug in 1 for the x. So y equals 1 squared, that'd be 2, minus 3 plus 1, y equals 0. Now, obviously, this equation does not represent that equation. I'm just making up a problem. But the important thing that I want you guys to understand is now that would be the y-coordinate. That's the x-coordinate of the vertex. So now I've figured out what the vertex is. And a lot of times we go with this formula for the vertex, opposite of b divided by 2a, which is the x value, and then f of opposite of b divided by 2a, which is the y value. And that f in the parentheses of that, what that means is to plug in the x value into the y value. That would be for, thinking about it as a function. I know we only have equations up here, but that's the idea. Find the axis of symmetry, find the x value, and then plug that in to find the y value, and that is going to be your vertex. And lastly, the thing we'll need to know is understanding end behavior. Notice when I graph my parabola, I want to make sure that by graphing the parabola, I want to make sure that this graph extends indefinitely. So we're going to continue on the graph. Always put those arrows in there. I get a lot of students, they'll just say, oh, I graph 2 points, and they just kind of stop, at the points. No, the parabola extends indefinitely in the directions that it's headed to. So there you go, ladies and gentlemen. Those are just some things that you're going to need to know in order to graph quadratics using in the standard form. Thanks.